Today we are going to solve problems based on binary search. Now the problem states find the median of two sorted arrays. We need to find the median of the resultant array, which will be after merging these two sorted arrays. For example, if we merge these two sorted arrays, we'll get 1, 2, 3, 3, 4, 6, 7, 10, 12, and 15. Now, after merging this, we will get median as the median of 4 and 6, which will be 4 plus 6 divided by 2, which will be 5. Now, the naive approach will be to merge these two sorted arrays using the merge sort algorithm and then easily find the uh, median. Now, a more optimized approach with binary search will be first we need to check how many elements from the array A or the first array we are getting on the left side. That will be 1, 3, and 4. And the elements from the array B will be getting are 2 and 3. Now the leftover elements that are from A that are on the right will be 7, 10, 12. And from the second array will be 6 and 15. Now, if you can observe here, obviously the elements coming on the left will be less than elements coming on the right. Now we need to check whether elements from last element from array 1 is less than the first element from array 2. We don't need to check array 1 and array 1 as we know both are sorted and the elements that will be on the left will obviously will be smaller. And so if we check this, obviously this 4 is smaller than 6, which means this is a correct division. And we similarly need to check the last element from array 2 on the left and the first element from array 1. Again, the element on the left is smaller and hence this is a valid division. Now, a wrong division will be 1, 3, 4. Let us say we add one more element from the left and the remaining element, let me correct, 7, and the elements on the right will remain 10 and 12. 2, 3, 6, and 15. Now, as you can see, this comparison fails as the element coming on left is greater than the coming on right, which is the wrong division. So we need to come up with such a division that the elements coming, this will is valid, but this is wrong. So the elements that are coming on the left will always be less than the elements coming on right. More specifically, the last element that comes from array 1 should be smaller than the first element that comes from array 2. Similarly, the last element that comes from array 2 on the left should be smaller than the first element that comes from array 1. Mm, Now let us check how many elements we'll have after at this partition. We see 1, 2, 3, 4, 5. Let's just say the size is n and size is m. Now at partition we will have n plus m divided by 2 elements. And now the max number of elements, the minimum number of elements that can come from array 1, that is A, will be let us initial L is equal to 0, and the max number of elements that is high will be minimum of n comma partition. So that there can be a case where all the elements from array 1 will be smaller than all the elements in array B, so all the elements will come on left. Otherwise, the maximum elements can be this number of elements such that all the elements are greater or mixed. Now, while L less than equal to H. Now we can label this as L1, this as L2, R1, R2. Our correct partition will be L1 less than equal to L2 and R1 less than equal to R2. In this while loop, we first calculate the number of elements that are coming from left, which can be termed as mid. We are calculating mid as we do in binary search, which will be L plus H divided by 2. Now these are the elements from array 1 that will be coming on left. Now the elements from array 2 that will be coming off left will be, let's just say C2 is equals to partition minus mid. This will be the number of elements from array 2 that will be coming on left. Now our L1 will be A of the last element that will come on here. So A of mid minus 1. Now our L2 will be last element from array 2, which will be B of C2 minus 1. The number of elements on left will be C2 and the index of that element will be C2 minus 1. The elements of on the left of from array A will be mid and the index of the last element will be mid minus 1. Now we got L1 and L2. Now we need to get R1 and R2. So R1 will be A of simply mid, the first element that will be coming on the right, and R2 will be B of C2. After getting all these elements, we need to check whether the number of elements we are considering from array A on left are correct or not. We will check by this. If L1 less than equal to L R, let me correct myself. The correct will be R2 and L2 less than equal to R1. I will correct now. L1 less than equal to R2, L2 less than equal to R1. If this condition satisfies, that means that we have found the right division. Now, after finding the right division, now we need to find the mid. Now, there can be, I'm sorry, median. There can be two types of medians for odd number of arrays and for even number of arrays, even length array. Now we need to find the total length. The total length will be T is equals to M plus N. Now, if T is median, is even. As we can see in our example, our T is even. Now our median will be the minimum from here, the maximum from between L1 and L2, and the minimum from R1 and R2. Let me, before considering, I will initialize the variables. Max left equal to max of L1 comma L2, and minimum from right is equals to min of R1 comma R2. Now if our total is not even, not equal to 0, simply our median will be the max element at max L. We will return else if we have even elements in the complete sorted array, merge sorted array, then our median will be min from right plus max from left divided by 2. We have to return this value. Now this is considering if we have got the right division. If this division fails, then we check if L1 is greater than R2. Now let's just see here. Our L1 is greater than R2, which means that we are taking extra elements from array on our array A on the left side. We need to reduce this, which means we need to reduce mid value, and hence we our high will be mid minus 1. If this is the condition, then our high will be mid minus 1. Else there will be another failure, which means L2 is greater than R1, which means we are taking more elements from the right, from the less elements from the array A on the left, which means we have to increment our mid value. This will be L is equals to M plus 1. Here our while loop ends. In this way, we will be calculating and returning. First, we will be continuously calculating the right division to binary search. After calculating the right division to binary search, we will check whether it's odd length or even length. If odd length, then max L will be our answer. If it's even length, then max L plus min R divided by 2. I hope you have understood. Now I'll be sharing the code. Now we can check. We are first calculating our partition, and this cut one is the mid value. We are considering cut one to be the number of elements on our from array A on our left side, and cut two will be elements from array B on the left side. Now there will be a condition, that is cut one double equals to 0. Our cut one can be 0. Hence we cannot access a dot cut one of 0. Hence we will initialize that to integer dot main value if cut one is equals to 0. If cut one is equals to m, we will initialize R1 to max value. Similarly, if cut 2 is equals to 0, we will initialize L2 to mean value. If cut 2 is equals to n, we will initialize R2 to max value. Now this is our valid division. By checking this condition, we enter into this valid division if condition. We calculate the total length m plus n and max length of L1, max of L1 comma L2, and min of R1 comma R2. If this is our even length, then 0.5 of max, that is equal to max left plus my min right divided by 2 if you are multiplying by 0.5. Otherwise, it is odd length, then we will just return max left. Else if we are considering more number of elements on the left from array A, then we will reduce it by high is equals to cut minus 1. Else we will increment it low by cut is equals to low is equals to cut plus 1. And we repeat this until we return our median. Now another problem we are going to solve is calculating the uh, square root of a number. Let's just say we get a number k is equals to 16. We need to return the value answer as 4. We'll first initialize our left to 1 and high to k. We'll find mid is equals to L plus H divided by 2, which will be 17 by 2, which will be 8. Now we check if mid into mid is equals to k. If yes, then return mid. We also have an answer variable initialized to 1, just in case, else if mid into mid is less than k. If it's less than k, then this could be a possible answer. So answer is equals to mid, and we need to increment values. Hence L is equals to mid plus 1. Else H is equals to mid minus 1. While we'll do this while L is less than H. L is less than equal to H. Now why we are considering this answer is equals to mid is, let's just say if the k value is not a perfect square, it does not have a perfect square. Let's just say it is 20. Now still the correct answer should be 4. Integer part will be 4. The answer will be 4 point decimal something, but the integer part will be 4. And hence when we get this 8, we'll check square 8 square is not less than k, hence we'll decrement our h value to mid minus 1. So mid h will be 7. So 1 plus 7 divided by 2, this here it will become 8 by 2, which will be 4. Now 4 square is less than equal, is not equal to k, but it is less than k. 16 is less than 20. Hence our answer will be mid. But we need to get to as close to 20 as possible. So we increment our L to mid plus 1. So L will be from 1 to 5. It will jump to 1 to 5. And our H won't change. And again, we will be calculating our mid value, which will be, let me, this while condition will be before mid, calculating mid, while L less than equal to H. Now mid will be 5 plus 9 divided by 4, which will be 6. 5 plus 9 divided by 2, which will be 6. Now 6 square is not equal to 20, and 6 square is greater than uh, our k value. Hence we will reduce h value to 6, h value to 5, 6 minus 1. Our L is also 5. It is while L is less than equal to H, which means L is equal to H. It will be true. We'll calculate our mid again, which will be 5 plus 5 divided by 2, which will be 5. Mid will be 5, and mid square is not equal to k, but mid square is not also not less than k. It is greater than k, hence we'll increment our h. H will be incremented. We'll reduce our h, which will be 4. Now our while condition fails. Since our L is 5 but our H is 4, and hence we'll be returning, uh, we'll be exiting our while loop, and our we'll be returning answer, which will be storing 4. I hope you have understood the two questions we have discussed so far. Thank you.